Welcome to the video on class 34. We're going to talk about types of discontinuity. There are four types of discontinuity that we're going to talk about. The first one is what's called infinite discontinuity. An infinite discontinuity looks something like this, where you have a graph, and let's say at 3, we have a horizontal asymptote. And it goes like this. Or sorry, a vertical asymptote. Now that vertical asymptote is what's called an infinite discontinuity. Because the graph will not touch x equals 3 at any point. At any point on this vertical line, it will not touch. So at x equals 3, there's what's called an infinite discontinuity. And infinite discontinuities are represented by vertical asymptotes. A jump discontinuity is something like this, where you have a graph and a dot there, but then it jumps and has an open circle and goes somewhere else. So there's a space here and it jumps. So basically, if you look from left to right, the graph goes from, we'll call this 3, goes from 3 to the left and then jumps down here and then goes from 3 to the right in this spot. This is what's called a jump discontinuity. And notice this is continuous on the interval of -infinity to 3 and union 3 to infinity. Alright, because notice it's not one big continuous thing, it's continuous to here and then it jumps down there and then goes there. Removable discontinuity is when you have a graph and it would be continuous except for one specific point. Let's say that this is 3 again. You have a circle and then it goes on forever. So basically at that one point, it's not continuous, but everything else is continuous. So this is a removable discontinuity at x equals 30. And once again, this is continuous on the interval from -infinity to 3 and from 3 to infinity. This does not include 3. The same with this one, the infinite is continuous everywhere except at 3. Now the horizontal or diagonal gap discontinuity, it looks something like this, where let's say this is 2 and it goes like that, but then you come over here to 3 and it goes there. So there's an actual horizontal or diagonal gap. It's not just everywhere. Like here, notice it goes to 3 and then it moves down, and then continues on the other way. But there's no x coordinate that it's not equal to, whereas here there is a horizontal gap from 2 to 3. So this is only continuous from -infinity to 2 and from 3 to infinity. So notice there's a gap in its continuity. So you might have the question, what is continuity? What is a function continuous? Well, a function is continuous at a point x if the graph can be drawn without lifting your pencil. So if you can make a graph without lifting your pencil, then it is continuous. So if you look at these two graphs, first of all, let's look at part one. Part A, is it a function? Well, this one for number one, this one is a function because it passes the vertical line test. Notice if you did a vertical line test at any point, it would be a function. What is the domain and range? Well, the domain, if you notice, there's arrows on the right, arrows on the left. It's continuous, so it's all real numbers. The range, if you notice, the very bottom of the graph is -5. The top, well, there's arrows going up, so the range is greater than or equal to -5. Now, is this continuous? Well, this function is continuous everywhere. So it's continuous on all real numbers. So there is no discontinuity. For number two, if you look at it, it is a function because it passes the vertical line test. What is the domain and range? Well, the domain, if we go from left to right, well, it's everything up to -3. And then it goes from 3 to 10. Sorry, -3 to 10 on the x. And notice it doesn't include 10. Notice it doesn't include 10 because it stops at 10 right there. The range, if you notice, it goes up in that direction there, and the bottom part is here at -3, so it's basically greater than or equal to -3. It's continuous if you look from left to right until it gets to -3. And then from -3, it's continuous to 10. And that's where it stops. What type of discontinuity is it? Well, if you notice, it would be continuous except for these except for these holes. So basically, this is an example of removable discontinuity. And it happens at two places, at x equals -3 and at x equals +10. That's removable discontinuity. All right, let's turn the page. All right, so let's look at number 1 here. Is it a function? Well, yes, it is a function. The reason why is if you did a vertical line, it would pass through. Now, understand you say, well, wouldn't it pass through right here? Yes, it would, but this is a circle, so it's not actually passing through the function there. So it is a function. Second, the domain, well, if you go from left to right, it is all real numbers. Even though there's some circles here, if you go up here, it does include that number. The range, the very bottom of the graph is -2, but then there's an arrow that means it goes up forever this way and that way. So it's basically anything greater than or equal to -2. Then it asks when it's continuous, and the function is continuous from -infinity to -4, or sorry, it's to -2, because that's right here, and then from -2 to +3, and then from +3 on to infinity. And then the discontinuity, well, this would be jump, because it jumps up, so jump discontinuity. And it's at two places, at x equals -2 and x equals +3. All right, so now we'll move on to the next problem. If you look at it, is it a function? And the answer is yes, it's a function. Because remember, even though these look like they're straight up and down, they actually go towards the asymptotes and they don't touch. What is the domain and range? Well, here the domain is all real numbers except for +2, because that's where the vertical asymptote is at. For the range is all real numbers, because if you notice there's an arrow going down and an arrow going up. So that's all real numbers. The function is continuous on the intervals from -infinity to 2, and then from 2 to +infinity. And then it has infinite discontinuity, because whenever there's an asymptote, there's infinite discontinuity at x equals 2. All right, that concludes our video for today. If there's any questions, please feel free to ask in class, and hopefully this will help you to be able to do your homework.